Sir, please start, sir. We are on live.
Hello, this is Dr. Prasad Ramanathan. I am a senior director at Capgemini Technology Services India Limited. I am leading the AI ML Center of Excellence within the Cloud and Infrastructure Services business unit of Capgemini, and I'm based out of Mumbai. Good afternoon, good evening to all of you. And today, my topic of discussion is going to be developing AI and ML applications responsibly. So this is a new area of, if you want to think about it as a research topic, as an applied research topic, whatever you want to give it a name, it is becoming a very prominent thing called responsible AI. So in this discussion that we are going to have in the next 45 minutes or so, we are going to look at what is this thing called responsible AI. First of all, why has this become an important field? Then we will look at what are the various constituents of responsible AI. How do we achieve some level of responsibility in the so-called applications that we deliver? And what are some things that are likely to come up in the near future? And finally, close it out with the Q&A session. So that is the broad agenda for today's topic related to responsible AI. Now, to set the stage for this, clearly, we must understand that there is a significant amount of increase in the adoption of AI ML applications in the recent past. Obviously, we are reading about it in the newspapers, but most of our interactions with this device called as a cell phone would probably let us get a view around what are some applications of AI ML which are already being made available through our mobile devices, which most of us have kind of a greater affinity to. We will probably not take our wallet, but we will never ever forget to take our cell phone. And if that is the case, then many of these applications of AI and machine learning techniques are being made available as part of this mobile device. So some of you may be wondering, okay, where exactly are we using AI ML? Clearly, if you're using an Android phone, the Google Voice Assistant or the iPhone Siri and so on are voice-enabled applications which will understand what is it that you are trying to communicate and will be able to give a response to that. Now, that is clearly one simple example. But then there are so many other examples that we don't even consider them as AI anymore. Even if we want to simply go from one place to another place, we use Google Maps or any other equivalent maps application. The ability to navigate from one place to another place and discover the fastest route, the shortest route, all of these are examples of AI applications. If you look at commonly used WhatsApp type of an application, and if you start typing in some characters, immediately it gives you the look ahead characters and words and things like that, so that you don't have to actually type in every letter of the words. So those are examples where, based on your interaction with your device, there has been a learning algorithm that has gone into place, which will identify what are those words that you most frequently use and how it forms a sentence. So as a simple example, if I were to send a birthday greetings to somebody, and the moment I say happy birthday, it immediately will respond with the subsequent words, happy birthday to you, many happy returns of the day, or wish you the best, or whatever it is. Those kinds of words will start coming up in a sequence without me having to worry about it in terms of actually typing the entire word. This is yet another example of how look-ahead typing is truly an implementation of AI ML applications, which we don't consider as AI anymore. but the number of such applications of AI are truly increasing dramatically. I mean, if you were to think about the camera sensor, the ability to discover faces in an image and be able to focus on those faces by putting bounding boxes around those faces, the ability of Facebook to discover that this image looks like somebody else's image in the friends circle or something of that kind. Those are additional examples of how image processing is used. Many of us are used to interacting with chatbots where we type in a message to a computer and the device starts responding saying most likely the answer to your question would be this, and are you happy or not happy type of a thing. Many banks, utility companies have started using this. So clearly there is a significant amount of rise in the applications of AI in the recent past, especially in the last 5 years compared to any other time in the history of mankind. Now, as Spider-Man says, with this kind of a power that is being exhibited by AI applications, where everything from navigating from one location to another location, or the ability to have autonomous cars where they will drive themselves, is the kind of power that we are seeing with AI applications. And like Spider-Man says, with great power comes great responsibility. So what exactly do we mean by great responsibility in the context of AI application development is what we are going to try and delineate and understand that in a slightly better manner over the next 40-45 minutes. So when we are building such applications which have got such a significant amount of intellectual capabilities, as we call it, in the context of applying AI, clearly we don't, or we always come across these fictional Hollywood type movies where there is a rogue AI which is going to control the entire world and all of the humankind is going to be subjugated and things of that kind. So we are significantly away from that kind of a doomsday scenario. At least for the foreseeable future, we don't have to immediately worry about it. But the ability of applications to learn based on data, based on patterns, and discover refinements to their abilities in an online manner, in a real-time manner, is something that we as data scientists, analytics professionals, AI professionals, we have to program our devices in such a way that they start behaving in a manner that is appropriate for the society and in conjunction with the law of the land, so to say. So what do I mean by that? I mean, so all of this is nice to hear about, saying, okay, there is a possibility of a rogue AI, it has to comply with the law of the land and all that. So the crux of the matter, as Accenture has put it in their paper, is how do I ensure that my AI solutions are designed to operate responsibly? Now, the choice of the word operate responsibly is something that I will start addressing in a slightly greater level of detail shortly. Similarly, how do I employ an AI application to act in a manner that is compliant with stakeholder applications and with the applicable laws? So if I am deploying an AI agent to do something, whether it is facial recognition, whether it is a chatbot, whether it is the look ahead typing, whatever it is it compliant with the law of the land? And is it compliant with the stakeholder expectation? If I start asking my device for something and it starts uttering some profanities at me, that is clearly against the expectations that I have as a stakeholder who is using this device. So am I creating an AI application that is compliant with the expectations and the expectations of the law is the other question that we have to answer. And the third is, clearly while doing all of this, we don't want to constrain our AI agent in a way that is not going to serve the purpose for which it was created. I need to unlock the full potential of my workforce and see that these AI agents are complementing my workforce to the fullest of their ability. That is also something that I need to worry about. So there has to be a balance On the one hand, it has to act responsibly, operate responsibly, and at the other hand, it cannot be constrained to a level where it becomes non-useful or it does not provide all of its advantages. I need to ensure that it is fully enabling my workforce for all of the capabilities that I have. So with this as a crux of the questions that are typically asked in the context of responsible AI, let us start diving deeper into each of these elements of responsible AI. So let me start with the top right here, compliance. Like I said, compliance essentially stands for the need to comply with the law of the land and comply with the expectations of the stakeholder. So when I am using AI agent, it must give me a level of comfort that yes, it is complying with the law of the land and it is also providing the stakeholder expectations. So as a simple example, if I start using a AI application, or if I start using an application, an e-commerce application such as that available from Amazon or Flipkart or whatever be your favorite e-commerce application, and if the application starts making recommendations of products that are not complying with the local law, then clearly there is something that is incorrect about that particular agent. And therefore, now an AI agent is only capable of doing what it is told to do, which means it is programmed to behave in certain manners, and that programming is something that the developer, in this case the data science person or the AI engineer, the ML engineer, is the one who is programming that AI agent. And therefore, while we are talking about all of these behaviors that we expect from a responsible AI agent, really speaking, we are putting the programmer, the developer, the ML engineer as the person who has to abide by these principles. And therefore, we need to comply with the local laws. And remember, local laws will be different from geography to geography. What is considered as acceptable compliant behavior in one geography or one region or one country may be non-compliant in another geography or region. And therefore the need to value the law of the land. This associated thing with that is what is typically called as ethical AI. Now, a simple example of ethical AI can be seen from this chart here, which talks about an autonomous vehicle which is programmed to follow a particular course. Now, when this particular vehicle actually comes across a situation where there is a man on the so-called zebra crossing, it has to take a corrective action. And if it takes a corrective action of swerving to its left, it will hit a barricade and may cause injuries to its owner. On the other hand, if it continues on its path, it may cause injuries to the pedestrian. Now, this is clearly a situation where at the minimum, one person is likely to get injured. And this is clearly a moral dilemma where who should this agent actually try and protect? Should it protect the pedestrian or should it protect its owner? These are obviously very, very difficult questions, and there is no correct answer in the context of ethics. But ultimate responsibility for making this choice is not with the AI agent that is actually running this autonomous vehicle. It is something that is programmed into it by the AI ML engineer, and therefore it is important that the ML engineer who is doing this development understands the situation and programs it correctly. So this is an example of what we call as ethical AI in action. And clearly, I don't want to make you believe that everything is going to be black and white and everything is going to be known a priori, and there will not be situations which are gray. There will be situations which are gray, and we have to keep improving this AI agent over a period of time in order to ensure that it complies with what human beings consider as normally ethical. Another aspect of this responsible AI is to make sure that it acts in a secure manner. Now, security, privacy, these are all independent terms and have very clear definitions associated with it. But in the context of a secure AI program, we want to ensure that your AI agent is not going to provide this data that it is using in a what you call, in a manner where it is going to learn from the data periodically and it is going to update its models. Those data continue to remain secure and are not shared with any non entity, or rather with an entity which is not supposed to be entitled to that particular type of data. So the ability of the AI agent in order to use the data, while that is acceptable, that data cannot be shared with others. Most importantly, in that context, is what is typically called as PII data, personally identifiable information. So if my Aadhaar number or my details of what kind of illnesses that I have are something that the AI agent is using in order to develop some models in the context of a medical diagnosis or something like that, then such personally identifiable information shall not be shared across with other individuals who do not have a need to know about it. So that is an example of how secure AI can play a significant role, and how, as AI/ML engineers, we must be worried about these kinds of facets related to responsible AI development. There is a subtle difference between interpretable machine learning and explainable AI. Let us understand what this means. Now, suppose I go to a bank and I request for a loan. Now, typically, the bank manager will take such parameters like my salary statement, my any debts that I may have, which I am still providing repayment on loans or something of that kind, any debts that I have, what is my age, in which organization am I working, is that organization a reasonably steady organization, and am I likely to be employed in the near future so that I can repay this loan that I'm seeking from the bank. So these are all parameters that a bank manager would typically go through in order to identify whether I am eligible for a loan. And for whatever reason, if the bank manager says, no, sorry, we do not consider you as a candidate who is eligible for a loan, you can definitely ask him, why did you come up with that kind of a decision? And the bank manager, as per the prevalent regulations within the country, is obligated to tell you the reason why your credit score went below a threshold. So is it because of my level of income? Is it because I have too much loans that I am already servicing? Is it because my company is not very stable and people or the manager expects that I may be out of my job very soon? Is it because I am already old, so old that I may not have a sufficiently long income time to repay my loan? So these are all examples of facets that the bank manager has to explain back to me, saying the reason why I had to reject your loan is because of A, B, C, D reasons. Now, suppose we had an AI agent which is doing many of these routine tasks of discovering the credit profile of a customer in a bank in order to determine whether that person is eligible for a loan or not. Now, in that context, suppose you use a AI algorithm which is not able to provide such explanation, and it just gives you a binary response saying, yes, you are eligible or you are not eligible. Clearly, if you were to ask the manager, why did I not get a loan sanctioned? The manager at best may be able to say, well, my trusted AI agent refused and I really don't know why. Now, that is clearly not an acceptable way in which an AI agent has to be delivered. An AI agent that provides assistance to a bank manager to resolve such routine aspects like discovering the credit score of a client who is coming into the bank. He must get a fairly detailed analysis of what were the various inputs that were considered and how they were rated in order for the AI agent to come up with a answer saying you either have a sufficient credit rating or you don't have a sufficient credit rating. And therefore, the ability to explain what the decision was is something that is very important in the context of such examples where there is a need to provide that kind of a explanation to the customers. Some of these are regulatory mandated. Some of these may not be regulatory mandated, and yet it is important. As a simple example, if I were to go to a doctor, and if the doctor says, I suspect that you have pneumonia or you have typhoid or something like that, there is no obligation on the doctor's viewpoint saying, well, I got this symptom, and based on this symptom, I'm suspecting this as your disease, and then I ran this particular blood test, and that gave me a confirmatory this thing. There is no obligation from the doctor's viewpoint in order to provide you that explanation. Most of us who are visiting doctors rely on the doctor's expertise to use the symptoms, to use the confirmatory tests and the pathological tests in order to come up with a diagnosis. And sometimes when we feel that it is probably not an accurate diagnosis, we can go to a second doctor for a second opinion, so to say. But ultimately, what are we trying to do? We are trying to explain the conclusion that the doctor has arrived at, and we are trying to figure out whether multiple doctors are able to explain the symptoms and the various parameters that they are seeing in a consistent manner. So that is what explainable AI is all about. Now, on the other hand, interpretable machine learning is all about the ability to come up with an answer or a model based on my data, and I am able to say, yes, based on this data, this is my model, and this model tells me that one parameter has a higher weightage compared to others. As a simple example, if I were to think about a linear regression type of a model that I have to come up with for a set of data, then that particular parameter or that particular variable which has got the highest coefficient is most likely the parameter that has got the highest amount of weightage. And therefore, I am able to interpret my result by saying, yes, in this linear regression equation, A0 plus A1 x1 plus A2 x2 plus A3 x3, A1 has the highest value, and therefore x1 is the parameter which has got the highest amount of weightage. So the ability to interpret my machine learning based models are also some things that we have to look at. So these are all examples of various facets of responsible AI behavior. Now, in this context, we have to start understanding how some of the machine learning algorithms that we have been exposed to can actually result in non-responsible behavior. So some of you may be aware that in 2016, Microsoft released a chatbot application called Tay, T-A-Y. This chatbot application was supposed to interact with people over Twitter, and it was an unsupervised learning algorithm where the expectation was that it would interact with people on Twitter, and it will use the responses provided by people on Twitter as a mechanism of discovering those topics or those clusters where there seems to be a greater affinity for people to talk about. So those kinds of words are the ones that are commonly used by human beings who are actually conversing over Twitter, and correspondingly the same kinds of words or that kind of cluster of words is what the chatbot will also use. That was the intention with which Microsoft had released this particular chatbot on Twitter. Now, unfortunately, some people discovered that this chatbot is learning things on the fly using the data that has been provided to it by other Twitter users. And correspondingly, what a group of people decided to do was to teach this chatbot a bunch of profane words. And very soon, within a matter of a week or 10 days, a group of people started teaching this chatbot to say utterances which are not acceptable as parliamentary language, so to say, so it started uttering profanities, it started cursing and things like that, which was clearly not the intent with which these developers had created this application. So immediately Microsoft had to take down this application. And the biggest learning from this is that when we as AI engineers, ML engineers start designing systems, we have to take this element into account, where not all the people who are using this application will have good intentions, and therefore there is a human element associated with these applications, and we have to safeguard our AI agent against the abuse of such people who do not always have good intentions. The second example is related to the explanation that I just gave you about the risk scoring system for loan approvals. And this is also actually a real thing that had happened. I'm sure if some of you go through the Google or go to Google and discover this, you will find that there was a fairly large IT service company which had created an application for a bank to create or to approve at least loans, whether they can be disbursed or not, had to be at least the routine questions we were able to classify and get some solution around it, or at least an answer around it. Now, unfortunately, you may know that historically there is a greater proportion of men in the workforce than women, and historically there is a greater proportion of men who are borrowers from a bank than women. And for an AI application to learn from historical data, it was discovered later on that one of the features was the gender of the applicant. And for the same set of parameters of age, income, debt, and all that, a male borrower would be approved for a loan versus a female borrower not getting approved for a loan. Clearly, there is a situation where bias in the historical data has crept in, due to which our AI agent has also become biased towards male borrowers. This is a inadvertent discovery, or rather an inadvertent feature that has been added to the model, and therefore the agent is now biased towards one particular feature which should not have been included in the first place. So this is yet another example in the real world where a responsible AI developer would now have to start looking at every angle of the data to discover whether there could be an inherent bias in my data which I need to be aware of, and correspondingly compensate for that bias. A third example is in the context of the facial recognition software. And all of us are aware of how Google Photos does a good job, or Facebook does a good job of recognizing image of a person and being able to tag other people saying, okay, I found your photo here, or I found your photo there, or this is this thing. So in Google Photos, I can actually search by name. I can say search for Prasad's photo, and it will come up with all the photos of Prasad. I don't have to search by image. And even image-based searching is something that is done using all of these image recognition technologies. Now, while all of that is great from a Facebook or Google Photos standpoint, many law enforcement agencies have sought permission to start using such facial recognition applications for a genuine cause, like locating missing children. Now, when you think about this cause this seems like a genuine cause and it seems like a perfectly genuine application. But then think about how in certain situations for certain rogue individuals in the government, this can become a tool of misuse. So instead of using it only for locating missing children, is there a way by which I can prevent a rogue person to start using it to continuously surveil a particular agent or a particular individual? So especially in politics or in those governments which are not considered to be open governments, democratic governments, in those kinds of situations, this is likely to be a highly misused technology where continuous surveillance of specific individuals, whatever they are doing, whether it is outside their home, inside their home, all of these become available for the so-called law enforcement agencies or the so-called bad guys to start looking at and use it in a manner that it was never intended to. So this is again talking about how certain technologies have a lot of sensitivity associated with it. And this is also the reason why in the recent past, Microsoft has very clearly said that our face recognition software will not be given to law enforcement agencies, or things like that are being talked about. So these are all examples of how bias in the data or the need for designing systems which deal with the people element or the human element or the sensitivity of the technology to certain misuse, all of these need to be worried about when we are building AI applications in the first place. So all of us as students of data science, analytics, machine learning, AI need to be aware of these things. Now think about it. Even 5 years back, responsible AI was not even a term that was used, but now it is an area that is being talked about significantly, and there is a series of conferences that are also being organized in order to establish this topic related to responsible AI. And almost all of the consulting companies, all of the IT service companies, and all of the machine learning as a service, that is the product companies, whether it is Google, Amazon, Microsoft, all of them have started building capabilities that will provide you this responsible AI activities. Okay. Now, PwC is one such example of a consulting company which has identified what they call as the 5 pillars around which the responsible AI framework dwells around. So first and foremost, they are talking about the need for a governance, which means that every application that is built for using AI technologies has to go through a review process, a process where the seniors in the organization will check whether it meets certain standards, whether there is any issue with respect to a set of checklist items, so to say, whether it is sensitive, whether it has taken care of the human element, whether it is have got any inherent bias and things like that. So there is a governance that serves as an end-to-end foundation across all AI applications. Now, ethics and regulation. The core goal is to ensure that the AI agent that we are building is compliant with all the applicable regulations and they are ethical in the first place. So this is yet another pillar, so to say, of the AI framework. We already talked about interpretability and explainability. That is, the AI-driven decisions must be interpretable and easily explainable to those who operate them and who are affected by them. So this is the third pillar, so to say, of the responsible AI framework. Robustness and security. How robust is the performance of the AI system despite variations in the data set or in the user community? And how safe is it? Does it have any implications in terms of data security, privacy, anonymization, personally identifiable information, and things like that? So this is another aspect. And finally, the bias and fairness associated with it. Oftentimes, we come across situations where As an example, in the US, there is a minority community which is typically the blacks in the US. And if you look at the number of convicts in the jails, there is a larger proportion of blacks in jails compared to the whites. Now, inherently, if you start using such data and of people who are of color and who are convicts, then there is an inherent bias against a minority community here. And if I'm going to use such an AI agent to identify what is the likelihood of a colored individual to become convicted, it is likely to the AI agent, based on the past data, is likely to suggest that a person of color is likely to go to jail more a number of times than a non-colored person. So therefore, such fairness in the AI system has to be built in by ensuring that the data is completely free of any bias and it is fair to all the parties who are likely to get impacted by it. So this is the so-called 5 pillars associated with the responsible AI framework that has come from one consulting company called PwC. The same kind of a thing is available from McKinsey or whoever be your favorite consulting company. Every one of them talks about a similar kind of aspects in the context of responsible AI here. Now, let us look at how product companies, that is Google, Microsoft, Amazon, how are they dealing with this aspect related to responsible AI. So as a simple example, I took a screenshot from what Google calls as responsible AI practices. And they have a specific website dedicated to only responsible AI practices. And as you can see here, these are certain examples of what they suggest as responsible or recommended practices for responsible AI. Clearly, human-centered design approach. So the ability to think about the person who is going to get impacted or who is going to use these applications is something that we have to think about. Identify multiple metrics to assess training and monitoring. Now, understand that there is a monitoring element with every AI data or AI model that we develop. We have to keep monitoring it to figure out whether that AI model or that ML model continues to be useful and usable, and whether there is a change in the data set in order to warrant retraining of the model. So whether that aspect has to be taken, or how can you identify metrics that will ensure that you now need to retrain your model and monitor it continuously. The ability to examine your raw data, the ability to understand the limitations of your data set, bias and things like that have to be looked at by human beings in order to discover such aspects. And clearly, you cannot underestimate the value of testing. And when you are doing testing, you have to test with completely unseen data from very, very different sources in order to ensure that some element of bias has not crept in or some element of sensitivity has not been overlooked and so on and so forth. And then continuously monitor and update the system after deployment. So these are the so-called recommended practice that comes from the giant called Google, which provides their Google Cloud Platform or TensorFlow and such other things in the context of responsible AI. Some of the other things that are there are overtones of what we have already seen: fairness, interpretability, privacy of personally identifiable information, and data security. These are all other facets of the responsible AI practice that Google has started promoting. Now, before we start thinking that, okay, Google is a giant and they are the only ones who are doing it, no, Microsoft is doing it, Amazon is doing it. So here is a set of features that Microsoft is following. And in the context of governance, they have These three so-called committees or offices, which are reviewing every element of Microsoft AI applications in order to verify that from a governance standpoint, all AI applications are adhering to the ethical standards that are required. So there is an Office of Responsible AI, there is the AI Ethics and Effects in Engineering and Research, or the Ether Committee, and then the Responsible AI Strategy in Engineering. So these are all elements of the so-called Microsoft approach to building responsible AI applications. Some of these are we have already seen, fairness, reliability, safety, privacy, inclusiveness. But the two most important things from Microsoft standpoint on which all AI applications are built on are transparency and accountability. So we already talked about transparency, which is the fact that AI systems should be understandable. This is nothing but the interpretability and the explainability of AI applications. So nothing new there. But there is one very important addition here, which is accountability. Now look at how Microsoft says that the people who develop this application should be accountable for the behavior of the AI system. The people are people like you and me, the students of AI, the students of machine learning. We are the ones who are accountable for the behavior of the AI system. This is Microsoft's stance. So as a trivial example, if I were to think about the autonomous car example that I showed you a few minutes back, and I say that this vehicle, autonomous vehicle, took a decision to kill the pedestrian or hurt the pedestrian in order to save the owner of the car, the responsibility for that or the accountability for that lies in the developer who wrote that program. And you cannot just hide behind a curtain saying, oh no, I cannot predict that because it is the AI agent who took that decision. No, the AI agent took that decision because sufficient amount of data was presented to that AI agent, which it learned, and that data inherently had the bias that it should protect the owner rather than a pedestrian. And that accountability lies with the developer of the system and not with the AI agent. So we cannot hide behind a curtain saying, I don't know why it took that decision. I have to be transparent and I have to be accountable as the developer of that AI system in order to provide the so-called comfort for the humans who are going to use it. So this is another important aspect of this thing. Now, Amazon has specifically come up with a module in their so-called AWS offerings, which is called Clarify. And this is a specific offering that is part of the SageMaker offering, which they call is their responsible AI offering. And what does Clarify enable you to do? Clarify has basically, at a very high level, it gives you a few capabilities. The SageMaker Data Wrangler is one such module with which Clarify integrates, and it helps you detect biases in data and imbalanced classes in the training set. So we already have seen how bias in data can result in a answer that comes from the AI agent, which is probably not accurate, or it is not probably a good thing. If you have to detect such biases, clearly as a human being, we have to do our best. But if the machine has a feature, if the product has a feature whereby detecting such biases becomes a lot more easier, then we should start using those capabilities also. So Clarify is one such example which enables us to use it in conjunction with the data wrangler to detect biases and also detect imbalanced classes. So this is one example. Similarly, in the experiments capability, it can identify biases in the model, and it can also try to explain the relative importance of the different features of the data set that go into the ML model. So this is yet another capability of Clarify. And some of you can relate this to the actual actions that we have to undertake when we are doing development in Python, that we have to do this manually of trying to detect biases or trying to detect the importance, relative importance of different features and all that. On the other hand, if there is a product that gives you at least a good 60-70% of it in a directly usable manner, then that will enable us to build these responsible AI agents in a more effective manner. And finally, the model monitor, which enables us to detect bias shifts over time. So especially as newer and newer data keep coming, is there a way by which I can identify that it is now time for me to train this model all over again with the new data, because this model is no longer representative of the current set of samples that I'm getting. So that ability to flag an event when you have to retrain your data, retrain your model using new data, is also something that Clarify provides you the capability of. So these are examples of how the product enables you or complements us to achieve the responsible AI capabilities. Now, where are we going with this? So what is next? The future of interpretability, if you read some of the these things, what you call articles that are being presented in various forums and things like that, they are talking about a model agnostic interpretability focus. So irrespective of whether the model is built using a logistic regression technique or a neural network technique or whatever it is, we have that is the ability to interpret the features in a manner that is model agnostic is one such area of focus for the foreseeable future. We are seeing a lot of research being done in this area. We are also seeing ability of the models that can explain themselves, which means, can we understand why a self-driving car took a decision to stop? And if so, was it the right decision? If not, why did it not follow what we expected to be the situation? And why did it not take the right decision? So if a self-driving car decided to stop, can it say that, okay, I decided to stop because I saw a red light, I saw a stop sign, I saw a pedestrian on the street, I thought I will hit something? What is the reason for the car to come up with that decision without just saying that, okay, in a neural network, this nodes got fired and therefore I believe there is a danger, and because I believe there is a danger, I stop the car. What is that perceptible danger that the car actually sensed? And what was it that it took as inputs in order to come up with that kind of a decision? If a car is able to explain that, then we can talk about it as an explainable model, and then we can use that in order to improve on the model. The same thing with respect to Alexa. When we say a sentence to Alexa, if it can tell us what went wrong and why it could not parse the phrase that we were talking about, then we can teach Alexa to learn that particular sentence or that part of a phrase or whatever it is in a more effective manner, so that in future it can respond to these queries in a more effective manner. And finally, increased model scrutiny. That is, with engineers and data scientists being held responsible for or accountable as models start to make mistakes, we as data scientists and machine ML engineers are the ones who will be responsible for anything that is not accurate. And therefore, the need for us to start looking at these responsible AI in a manner that is not merely a topic that has to be learned as a theoretical thing. We have to start building these models in a more responsible manner. So that is the other thing that we are supposed to look at. So hopefully in this webinar, you got a sense of what responsible AI is all about, how certain consulting companies have come up with frameworks which enable us to look at different facets of responsible AI, how product companies like Google, Amazon, Microsoft are betting on certain parts of their product, which will enable us as machine learning engineers to deliver more responsible AI agents going forward, and the need for deep learning applications, particularly deep learning type of applications, to be able to explain which are those features in the data set that parts of the network are using in order to come up with a particular classification or whatever be the problem that you are trying to solve. Those are examples of how responsible AI is going to make a significant impact for all of us in the data science community. So with that, I am done for the so-called formal presentation that I had to make. We have about 10 minutes here, and what I'm going to do is to start looking at some of the questions that some of you may have put on the Excel sheet that has been shared with you, and try to answer some of these. So the first question from Anand says, is there a certificate for this program, ML applications in day-to-day life? Well, at the beginning of the webinar, I did give you a bunch of examples of ML applications in day-to-day life, especially those involved in our cell phone. And as far as a certificate for this program is concerned, there is no certificate that you will receive for attending this particular webinar, but I'm sure if you enroll in the data science program, there is a degree that you will get. Okay. Then there is a question from Suraj says, please send me the code and how to develop ML model using Flask and Django. Well, this particular program was not about the code. So that is a completely different question. I don't know what that stands for. Shantanu Banerjee says, I wish to know more about ML in quantum computing and how we can work them together. Well, quantum computing is a computing paradigm that enables us to achieve a much higher speed of computation, and therefore some of the deep learning algorithms which are probably taking much longer to train and test and deliver can possibly be speeded up using quantum computing processes. I'm not an expert in quantum computing other than knowing that it actually enhances the speed of computing by many-fold, and therefore the need to look at those kinds of application or ML models that take a long time to develop are the ones that could possibly be candidates for quantum computing. There is a question from Sania Maheshwari which says, many critics of explainable AI argue that interpretability is not the issue. Instead, we must focus on testing. If a black box model is rigorously tested in a variety of situations and found to behave in a reasonable manner, then that is enough to earn trust. What is your opinion on this? And at this point in time, Sania, the only tool that we have today is really testing. And even if you saw the slide that I showed from Google, it says test, test, test. That is the key message that is being communicated by Google also. So in a way, at this stage in the evolution of explainable AI, while there are tools that will enable us to discover bias and things like that, or the need for retraining model, the one thing that we cannot overlook is the need for testing. So that is something that is, I fully agree with you on that. Yeah. Spurti Saxena says, what are the popular languages to write ML programs other than Python? Well, there is all of these ML as a service platforms, whether it is from Google Cloud Platform, whether it is AWS SageMaker, whether it is Microsoft Azure ML. These are the platforms of choice. And while they all support Python and R, they also support drag and drop based things for relatively simple models to be created. And those are the so-called programming paradigms of the future. So going forward, we will probably have lesser and lesser people writing code in native Python and more people using these platforms that come from Amazon, Google, Microsoft, and so on and so forth. How ML program differs from a program for optimization? Well, optimization is a technique that we use in machine learning to identify the best parameters that will explain or that will fit the data. So ML is typically a program or a agent that correlates the inputs and the outputs. Optimization is a technique that you use in order to minimize the error or things like that. Okay, so ML or optimization is used by ML. Can you show an example of an implementation of an ML program and a snippet of that example? Clearly, the topic of today's discussion was responsible AI and not really implementation of an ML program, but there are enough open source examples of ML that you can use in order to look at that. Kalpesh says relationship between AI and applied mechanics. Use of AI in mechanical engineering is what I presume that Kalpesh is asking about. Quite frankly, I would defer that question to a person from the mechanical engineering background. I don't think there is any, or your imagination is your only limitation in terms of discovering where you can apply AI. Okay. Then there is a question on are these industry sessions for placement that we get after this course? Well, these are more sessions where industry practitioners are sharing their experiences and the so-called advances in the field, and where we as students of data science must go and look for additional inputs, because not everything that is covered in the class of our curriculum is compliant with what is needed in the industry. So these are examples of where additional things need to be learned. Okay. Question, is this a part of data science? While this may not be a formal part of your data science curriculum, this is clearly something, there is a continuous learning journey that you have to undertake. What is the major difference between AI and ML? Well, machine learning is a means, is one example or one technology enabler for AI. There are enough, I'm sure you can search for that and you can discover that. There is a question from Professor Umesh, which says, I would like to share today's PPT with some of my third year students. Can you please send me the email? Okay, we can do that. Then in which platform you develop ML applications? Like I said, ML as a service, Google, Amazon, SageMaker, and Microsoft Azure are the things that are available. What are the various applications in the field of medicine, surgery? There are quite a few applications. I would request you to look through these things on Google, and you will be able to discover these kinds of things. Provide the link for access PDF in Accenture. This entire PDF, or rather this entire PPT, has all of the sources that are there at the bottom left. So you can go through that and you will be able to search for all of these. There is a question saying, can freshers start career in ML? Absolutely, yes. There is this entire BSc course in data science is meant for freshers only. So absolutely no reason why a fresher cannot get started on it. There is a question on legal AI, our ideas and views about how AI can use to automate some legal procedures in AI. Well, the simplest use case for legal professionals is to come up with the most appropriate case history for that particular situation. So can I index all of my past judgments that have been received from the various courts, and based on the topics that are listed in those judgments, can I bring up the most relevant judgments for the present case that I'm handling for my client? That is the most common legal AI requirement. Please share this video. This is on YouTube, so that is there. There's a question on where does the future of ML AI in the sector of economics lie? Again, quite a few number of economic models that can be created with this. We have very minimal time to get into the details of this. What other questions? What if responsible AI goes wrong? If responsible AI goes wrong, it is the developer who will be accountable for it, and that is what all of these companies are talking about. Then give some legal compliance. I was saying, okay, so I think those are most of the common questions that are asked here. There are quite a few other questions which are related more to do with AI, machine learning, and things like that. And those kinds of questions can be readily answered by doing a simple little Google search. And we have practically reached the top of the hour here. It is 1900 hours, and it is time to stop this session. So once again, thank you all for attending this session. Hopefully this gives you some food for thought in terms of how you will build your AI applications going forward in a responsible manner. Thank you all. And thanks to IIT Madras for giving me an opportunity to share my views on this also. Have a good day. Bye.